Hello everyone, this is Ranjit, Assistant Professor, Department of Computer Science and Artificial Intelligence, SR University, Warangal. In this session, I would like to demonstrate two protocols of the network, that is Address Resolution Protocol and Internet Control Message Protocol. So these two protocols are essential when a system wants to communicate with another system over the computer network. So before discussing these two protocols, first I would like to explain the addresses of the systems which are connected to the network. So based on these addresses, this ARP protocol or ICMP protocol is going to work. So first, let us see, just here I will explain the overview of the addresses which are associated with the devices connected to the network. So any system that is connected to the internet. So in this diagram, I showed an example that here two systems are connected to this side and remaining two connected to this side. This is one network, this is another network. Each device connected to the network contains two addresses. So one is IP address and MAC address. So IP address can also be called as the logical address or virtual address or temporary address, because these IP addresses will be changed from one network to the another network, and these IP addresses will be assigned to the system by the network administrator or assigned dynamically by the DHCP server. So based on the network the system is connected to, these IP addresses will be changed. So that's why these are temporary addresses or logical addresses or virtual addresses or simply IP address. Now coming to the MAC address. So MAC stands for Media Access Control. This address can also be called as a physical address or permanent address. And these addresses will be assigned to the system whenever that system is manufactured. So manufacturer will assign this address. And this address is the permanent address. Once it is assigned, that is unique throughout the world, and no two devices have the same MAC address in the world. So when a system want to communicate with another system, so these two addresses are necessary. So these are required. So we need IP address and MAC address of the destination. Then only we can communicate with the destination system. So your MAC addresses are permanent, and these are 48-bit length addresses, and these are assigned to the system by the manufacturer. Assigned to the system means assigned to the NIC, network interface card. So every system has network interface card. So to that card, this network cable is going to be connected. And generally these MAC addresses are represented in the hexadecimal form, and its length is 48 bits. So here, this is an example for the MAC address. So here, how many parts here? 6 parts are there. Each part is separated by the colon. 6 parts, and each part size is 8 bits in length. So these addresses are represented in the hexadecimal representation. So in this example, this IP address showed in the decimal representation. So IP addresses are temporary, and under IP addresses we have IPv4 and IPv6, but most commonly used IP addresses are IPv4 addresses. So these are 32-bit in length. When these IPv4 are exhausted, so then IPv6 will be used. So this is 128-bit length. The IPv4 length is 128-bit. Okay. So this is just an overview of IP address and MAC address. So just imagine that we are sending a letter or a message to the system which is connected to a network. So there, For example, here we have only the IP address. With the help of the IP address, when a data is sent, for example, we are sending some data or message from this system and assume that this is the destination. So this is one network, network 2, this is network 1. So from the network 1, we are sending data to the network 2. So while sending, so this source system knows the IP address of the destination, but not MAC address. So since we don't know the MAC address, only with the IP address, so we can send the data up to its network. So up to here. So to this router, this network is connected, but in this network two systems are there, out of which only one system is the destination system. So, but we don't know the MAC address of the destination system. That's why this message cannot be delivered to the destination system. By using IP address, we can send the data up to only this network. So in this network, means up to here we can send, but in this network, two systems are there. Then we need the MAC address. Based on the MAC address, so we can deliver the data to exact destination system. So that is the reason why we need both IP address and MAC address. So with the IP address, we can send the data up to the network of the destination. So, but on that network, there will be many systems. So in order to deliver the data to exact system, we need MAC address. So in order to know the MAC address of a particular system by using the IP address, so here ARP protocol will be used. Because only with the IP address, we cannot communicate with the destination. So from this IP address, in order to know the MAC address, your ARP protocol will be useful. So address resolution protocol. So this protocol will get the MAC address of a destination from its IP address. So once we know the MAC address, so then we can deliver the data to the destination system. So once this ARP packet determined or obtained the MAC address of the destination, then ICMP protocol will be used. Next, ICMP protocol. So that is Internet Control Message Protocol. So ICMP protocol will be used, and this protocol will send a packet from source to the destination. Just assume that PC4 is the destination. So what this ICMP protocol does, ICMP protocol send the packet and knows whether the destination is reachable or not. So will there be any packet drops and how long the destination is? So in order to know that, the ICMP protocol will send the data packet from the source system to the destination, and in return, destination will reply to the source. So now if there is no packet loss, then ICMP protocol will decide that communication can be started. Means the destination is reachable, so communication can be started. So then actual data after the ICMP confirms that destination is reachable. So then actual data will be sent from the sender to the receiver. These are the roles of ICMP protocol and ARP protocol. So in order to know whether the destination system is reachable from the source system, we have a ping command, the well-known command ping command. So using the ping command, we can know whether the destination is reachable or not. So we are typing ping command means, so indirectly we are creating one ICMP request packet to know whether the destination is reachable or not. So these are the roles of ICMP protocol, ARP protocol, and a basic overview of addresses, that is MAC address and IP address. Okay. So now I would like to simulate this ICMP and ARP. So from this theoretical explanation, I will conclude that. So when a system want to communicate with the destination, first ARP packets will be sent to know the MAC address. Based on the MAC address, next ICMP packet will be sent to decide the destination is reachable. So once it confirms, so then actual data will be sent from the sender to the receiver. So these are the 3 steps needed. So in order to start the communication between sender and the receiver. So now I will show you the simulation of this ICMP and ARP protocol. So for that simulation, we are using packet tracer. Just open the packet tracer. Here packet tracer is open. Now in order to simulate, first you take 3 systems, 3 or more depending on your interest. You can take this. Just to press Control or click this symbol PC. So here I am taking 3 PCs I am taking. And next you select one switch. So switch is a connecting device. So we discussed how to use switch and how to make the connection in my previous videos. In the same way I am connecting. So here 3 systems are connected. So once connection is over, now assign IP addresses for this IP config. So I am assigning 192.168.10.1. This is class C address, any class address you can take. You close this and take a note just to. So this is the IP address of first one. So next you assign another IP address to this. Go to desktop IP configuration. So 192.168.10.2 I am taking. So now close this. Now take a note and I am writing here. So this is your class. This is PC4 address. Next for this last system, go to the IP configuration. This is 192.168.10.8. So now take a note and write here its address. Now all addresses have been set for these 3 systems, and whenever we are sending a data from one system to another system, each system maintains one ARP table. So based on the ARP table, system can communicate with the other system. It contains IP address and MAC address of the destination. Okay. So you click on the simulation. So before going further, here you can find here search button. You click this search button. So you place the cursor on this button, you get inspect. Click that, and on the first PC, right click. You can get your ARP table. Click on the ARP table. So look at this ARP table. No data available here. Empty. So similarly, click on the second one and just you reduce this size, and this one also empty. So this is PC3, this is PC4, and this is also empty. Similarly, this ARP table. So this is also empty. All systems ARP is empty. That means no IP address, no MAC address. Right? Now let us see what happens. We have to simulate. You click on this, click on the first PC. Assume that from the first PC, we are trying to communicate with the third one, this one. Okay, 192.68.10.3. So click on the first one, command prompt, and first you test the same. These ARP tables are empty. So here also we can check that. You type here ARP hyphen space hyphen A. So look at this here, no ARP entries. Means because ARP table is empty. Now from the first system we are trying to connect this third system, this address. So here you type ping space 192.168.10.3. So this system. From this system we are trying to connect with this system. So after ping you press enter. So here you can find pinging this system 192.168.10.3. So no response, only pinging. Just minimize. Here two packets will be created whenever you type ping. So two packets will be created. So just keep your cursor on this packet. It shows ARP. Type ARP. Click on the second one. Type ICMP. Two packets will be generated. Okay. Now you click on this simulation. Play button. And stop here. You click this PDU. So in the PDU here you can find on the outer layer. So you can find here ARP packet source IP address 10.1, destination IP address 10.3. And here 0050 something here we have. So this is MAC address of the source. And after that here you can find all F. 4F, F. Because I already told you MAC address represented in the hexadecimal, and the hexadecimal each digit is range from the 0 to 15. 15 means F. Here F written means maximum number written. So that means this address represents broadcast address. Broadcast address means from the switch, the packet will be delivered to all systems which are connected to the switch. Okay. So just to remember this point, this is broadcast address. Next here you can click this inbound PDU details. In the PDU details, here you can find source MAC address and source IP address and target IP address, but there is no target MAC address. Using ARP protocol, we are trying to know the target MAC address. That's why here MAC address is all 0, target MAC address. Okay. So now close this. Just remember this point here in the OSI model. Target IP address is all F, means that is MAC broadcast address. That means this packet has to be delivered to remaining two systems except this source. Now again play. It is going to all systems, but here you are getting into mark. That means this is not the destination we are trying to connect. So in this packet, we have the target IP address. That IP address is not matching with this. Just like I showed you. So that's why this is empty. And this is received. Here no into mark. So inside this PDU, target IP address is there. That address matches with this IP address. Okay. So that's why here no int marking. Here you can find this ARP table has been updated. Earlier there is no entry here, but here it is updated with the source IP address from where this PDU has been received. And the next one, so next one, MAC address of this system, source system, right? So now, but here there is no IP address, MAC address of the destination, but the destination has IP address and MAC address of the source, because this packet carried IP address, MAC address of the source to the destination. Now in return, it will carry the IP address and MAC address of this destination to the PC1, means this system, source system. So now again play. So you stop here. You click this video. Now you can observe here. It is coming in reverse. That's why here source MAC address changed. Destination MAC address becomes the this system, source system. Earlier this was reverse. Now here ARP packet source address is 10.3. Destination is 10.1. Earlier reverse. Okay, that has been changed. So similarly, click this PDU details. So earlier target MAC address now was 0, but now target MAC address is there, target IP address is there, source IP address is there, and source MAC address is there. Right? So earlier target MAC address was 0. Now that target becomes source now. So now look at this, source MAC address is center in the PDU. Now here source MAC address, source IP address, destination MAC address, destination IP address. 4 addresses are available. Now choose this, click display. So look at that. Here you get a green color tick mark. So that means packet from the receiver destination reached at the sender. Once it reached at this place, here this ARP table has been updated with the IP address of this destination and MAC address of this destination. Earlier there was no entry here. Once this packet has been reached at this source, then this ARP table get updated. Now here we have the destination IP address and MAC address, and here we have the source IP address and MAC address. Now these two can communicate. Now only ARP sending and receiving is over. So now ICMP will be sent. Now click on play. You stop here, ICMP reached at this place. So just you keep the answer on this packet, you can find here name ICMP. Earlier ARP protocol sent and received over. Now ICMP protocol sent. Now again click on the play. Reached at the destination, and from the destination coming back to the source. Now over. Here tick mark. Means ICMP sending and receiving is over. Now there is no data loss. So once this ICMP reached, so then our actual data can be sent from the source to the destination. Okay. So now earlier we used ping. When ping command typed here, only ping was displayed. But now here you can find replay also displayed here. That means ICMP protocol sent from the sender to the receiver and sent back to the sender. So that's why here this byte, so how much time it is taking? 8 milliseconds. Okay. So bytes, 32 bytes sent. and how much time it takes, whether it is reachable or not. So that data will be carried from the receiver to the sender. So after this data can be sent from the source to the destination. So here also, so look at this ping. After ping command, here loss will be there. Loss 0. So loss 0 means no packets have been dropped. That means that communication link is clear from source to the destination. So data can be sent from source to the destination. So here also you can see earlier when ARP was typed, it showed no entry. Now you can also type here ARP -A. So now you can find here destination IP address, destination MAC address. This is similar to the system 1. So you can find here system 1 IP address and MAC address ARP table. The same data is available here. So in this way also we can check. So similarly you click on this one, go to command prompt ARP-A. So look at this now. This is ARP content similar to this table content. First system IP address, and this MAC address also. Right? So if you want to check whether really these MAC addresses are correct or not, so you can check. So I want to check this system MAC address. So this system MAC address is available in this destination ARP table. So you click on the first system, command prompt. So here we have the command IP config space /all. So here you can find the MAC address, physical address of the system 1. So where is this MAC address? So look at this here, physical address of the system 1. So that is available in the system P, means this destination system ARP table. Both are same. Similarly, IP address also 192.168.10.1. So look at this here, 192.168.10.1. This is the way of checking MAC address as well as IP address of the system 1. Now you want to see the system 3. System 3 details available in the ARP table of the system 1, means this source. So this is the destination. Now same process, click this command prompt. So here you type IP config. If you type only IP config, only IP address will be displayed, MAC address will not be displayed. So in order to get the complete details, IP config space /all. So here we can see this is the MAC address of destination. So here also MAC address of destination, both are same. Similarly, this is the IP address of the destination. So here IP address of the destination available in the ARP table of the source. So these two are same. So in this way, ARP protocol and ICMP protocols are going to be used before actual data is going to be exchanged. So this is a demonstration of ICMP, Internet Control Message Protocol, and ARP protocol. This video is informative. Thank you very much for watching this video.